Hi there, and welcome to another episode of Richie's Robots. In this episode, I'd like to show you how to use a $2 motion sensor to be able to control your Hue lights and be able to turn them off and on when they detect motion. It'll be fully customizable. You can set the time that you wish to do that and the sensitivity of the motion sensor. So you can use your own motion sensor with an ESP32 in place of buying a $30+ sensor from Philips. So welcome, and let's go on with it. Okay, so let me just explain how the actual sensor is constructed and how it works in a quite a simple way. If you look at the right in the picture in front of you, you'll see that there's a white dome. Now, this is a passive infrared sensor, PIR sensor is commonly referred to. Underneath that white dome are a pair of pyroelectric sensors that are able to detect heat energy through the use of infrared. Now, if that dome was not there, both sensors would be looking at the same object in front of them in the same way. And for the sensor to work, it needs to detect a difference between the two sensors in the heat energy that it sees. Now, what this lens does is it's actually a Fresnel lens, and it has a series of concentric grooves. This disperses the images it sees and allows both sensors underneath that dome to see the same object, but from a different angle. What then this allows is, of course, for it to be able to see any changes because they're both looking at it differently. Changes will only occur when the object actually moves. Hence, it's able to detect the detection. Okay, so just quickly to break it down, without the lens, the sensor sends out the infrared signal like this, and let's just put a line to separate it. They're going to be parallel to each other. So as the device comes through, it's not going to create a difference between the two sensors because they're only going parallel. What the lens does is it messes with it via these concave divots in the lens. So this one goes and then straight out there, and this one goes and then straight out there too. Straight out, straight out, straight out. So as you see, you get a much wider range, plus the sensors, the signals from both of them are very close together in each direction. So as the object comes through here, it is going through very quickly each of the signals and creating that heat change. So it detects the change in the heat via the infrared signal from the sensor, and it can then detect that something is moving at an angle of about 160 degrees. So that is the purpose of putting that lens on top of the sensor. If you didn't, you'd have to make it much wider, and that would make the sensor wider, which would make the device that it has to go into wider, which is not what we really want. If we go to the left, we see that there is a time delay control. This allows you to go from 3 seconds to 300 seconds, which is 5 minutes, between the time that it starts to sense something. So for instance, you turn all the way clockwise to as far as it goes, it will be set at 300 seconds. This means that it's after it detects one object, it is not going to start trying to detect until after 300 seconds. If you wanted it to check for movement every 3 seconds, then it would try to detect changes and movement every 3 seconds. The next on the left is the sensitivity control. The sensor has a range of 3 to 7 meters. If you rotate that yellow potentiometer clockwise, it'll increase it all the way up to 7 meters and decrease to 3 meters. And that is simply how far it's going to detect an object away. Now to the left of that, you'll see the BIS S0001 controller, which basically is the brains of the sensor. It does all the controlling. It has some noise immunity techniques. It creates some stability within receiving the signal and checking for changes so that it doesn't give any false positives, and is probably one of the best controllers on the market currently. More information about that chip, including a complete technical overview, you can find in a link here. Moving on, we have the 3 pins. We have a ground pin, the output pin, which basically just sends a signal when it detects a movement, and the voltage pin. It requires 5 to 12 volts. It can run on 3, but it's not very stable. The 3 volt regulator, which is next to it on the right, really needs at least 5 volts to come in. And all that 3 volt regulator does is make sure that the voltage stays at 3 volts because the sensor actually runs at 3 volts. And in a nutshell, that is basically the sensor that we'll be using for this demonstration. Okay, so let's have a look at the code that we're using for this project. As some of you might have seen in one of my last episodes, I did a YouTube film on how to communicate with the Hue Bridge and how to set values for the lights and to get values for the lights. So I'm not going to go into too much detail with that. So stepping through the code, you'll see here at the top there that we're using the Wi-Fi client and the Wi-Fi library or header. We then have the values for the Hue Bridge and our Wi-Fi network values that we need to connect, as well as the API you need to connect to the Hue Bridge with. We're going to be using, this is just the port that we're using to connect with the Hue Bridge on. We're going to be using pin 2. We're going to connect the motion sensor to that. And in my environment, I'll be controlling light 26. Just briefly, here's a link to the other film. If you haven't seen it, I do advise you first watch it quickly because it will allow you to have a bit more sense of what's going on here in terms of what a light ID is and what this function does and so forth for the Hue Bridge. Moving along, we create the Wi-Fi client. We have this function here to set or control a light bulb on our network. Here is the function to connect to the Wi-Fi network. And here is the function to reconnect in case we're disconnected, and we always check, are we connected to the Wi-Fi network? If not, reconnect. So we come down here and we set the motion sensor pin that it's connected to, pin 2, to an input pin, because we're telling the ESP32 to listen on that pin. We're not going to push data out on it or signals out on it. We're going to listen to it. As we come down, we have this little loop file here, looper routine, and we are basically saying if the pin is at high mode, which means a signal has been detected, a motion signal, then we know that motion has been detected. We do a little serial print line just to, for debugging purposes. We then set the hue value, which turns the light on. So it sets the value of on for this light, which was 26, to true. We then wait 10 seconds, which is 10,000 milliseconds, and then we turn the light off. And then we give a serial print line, lights are off. And that really is the entire function. We can increase that to what we want, so that we can say, well, if we want the light on for 5 minutes, then you would increase that to 5 minutes, and so forth and so forth. And that really is it in a nutshell. So now if we just have a look from the external view, we can see here it's connecting to my Wi-Fi network. And it needs to do that, of course, to communicate with the Hue Bridge. Once it's done that, you'll then be able to see, and it's in motion. So let's turn the light on. We'll wait for 10 seconds for it to go off. It's gone off again. As you can see, it's told us that the lights have gone off, but then it's already detected that we've gone close enough, because that's quite a wide range. It's about 160 degrees. So if we move it this way, we should be able to get away with already, and just wait. Now, wait for it to go off again. See, it's now off, staying off. Put a hand in front of it, and it's on again. So, thank you for watching another episode of Richie's Robots. I hope you really enjoyed it, and you got a couple of things out of it. The best would be that you could make this little sensor with an ESP32 yourself for a couple of dollars and save 10 times the amount, as opposed to buying one from Philips. It's not a hard thing to do, and I hope I've given you a good step-by-step way to do that. And of course, you can always just grab the code and do it yourself quite easily. And you're always welcome to ask me for any help if you need any, if you get stuck on anything when you're building this little project. Any comments is always welcomed. What I'm going to do in a future episode is I'm going to build on this. I'm going to add a light sensor so that when the motion sensor turns the light on, then, for instance, if it's pitch dark outside, you don't maybe want the light to be on at 100%. Because, you know, you don't need it to be so bright. It's quite irritating when it's dark and the room's dark and you all of a sudden got a very, very bright light. Usually you only need it at about 50%. So you can, I'm going to make the program so that you can customize at what amount of light that's already in the room you want the brightness of the bulb to be. And I'll be doing that in a future episode, so please stay tuned. As I ask kindly, if you can, please subscribe. That's always welcome. You know, it's not much effort on your side, and it really, really helps us when you subscribe to the channel. And nothing. Take care, and see you next time.
Using